Okay, today I'll be walking you through a Wi-Fi site survey for a client here in Cambridge. Wi-Fi site survey is what you do in order to see the signal propagation in an environment, whether it's a warehouse, it's a restaurant, an office, whatever kind of business you run. It's important you see how the Wi-Fi signal behaves in your environment. Before we start, I'm going to show you the tools that I'll be using. First off, it's my MacBook. The software I'll be using works on a MacBook. It's called Amina. My iPad. I will not be using my iPad today, but typically for this type of environment, I think an iPad will be more than enough, but I'll be using my MacBook today. You want a notebook, it's important you take notes because you're going to discover something new while you're doing the survey. And last but not the least, the battery. This is if I'm in an environment that requires me to survey for a long duration of time. The more power you have in your battery, the longer you can do your survey for. This is the most important guy. It's Osium. It's a device called Nomad, and it's made by a company called Amina. This device captures the entire RF signals that propagate within this environment. It captures 2.4, 5 gigahertz, and 6 gigahertz. It's extremely important, and the entire survey we'll be doing today will be reliant on this device. Stick around to find out how we conduct the survey. All right, so now that I'm done showing you the equipment we'll be using, I'll set up the project on my MacBook. I'll call this special client because I don't want to put any information here, but this is a real client. We're in Canada, root, then we'll add a floor plan. I already have floor 3. I'll upload the floor plan. So it's very important you set the scale. The scale helps tell the algorithm a form of measurement in 2D so it can properly map your signal coverage. Once we've done that, the next thing is to build out things that are walls, hard areas, etc. But for now, I'm going to show you how we connect the Amina device, the Nomad. Okay, this goes in here, and the other end goes to your MacBook. Once it's in, you're gonna power it on. It'll come up with a blue light. We'll go into the Nomad, and we're gonna wait for it to show up here. Eventually it'll show up in here. I'm gonna do all the editing. I'll just make this a screen recording, and I'll have this screen recording show up on the video before we start the survey. Stick around, okay? All right, so we have my Nomad. You can strap this any way you want. You can put it around you. You can hook it this way. Some people have it like a collar, whichever method works for you. I have my laptop. I have the floor plan. And we're simply going to start from here with a continuous survey. So you're going to see me moving around on the screen. The camera is going to follow me around while I do this. You might not hear me talk, but if there's anything significant that I need to bring up, I'll let you know on the video. So stick around, watch me do this. Let's go. All right, that concludes the survey. As you can see overall, this environment looks to have very good signal. Typically, if you have a lot of problems in your environment, I'll be able to capture and see what the problems are. So once the client tells me exactly what they want me to check, it depends. Some might want to have a stronger signal for a specific Wi-Fi broadcast, or maybe they want to target a specific appliance, or they want to target a specific device for their operations. With this survey that I just did, I now have enough data of the live environment that I can provide any feedback for any solution they're looking for, especially if it requires a wireless technology. This is pretty much how a Wi-Fi survey is done. Like I said, this is a very simple environment. And the reason why this is faster is because I have Amina Nomad. It captures the frequency live, especially with a continuous survey. If you're using the cheapest software, it'll take extremely much longer and it is more complex compared to Amina. This is not a promo, I'm not sponsored, but that's just how good the solution is. I'm gonna do more editing on my computer. Watch me do the finishing touches. Catch you on my PC. All right, survey is done. We walked the entire building. Overall, in this building, the signal coverage, actually, if you come close, signal coverage is very good. Okay, what signal coverage just tells me is 802.11, specifically 2.45 gigahertz and 6 gigahertz are being propagated within this environment. And if I want to filter it by 2.4, I can see exactly how the 2.4 signal propagates. So this tells me this environment is very strong for 2.4. 5 gigahertz is pretty okay as well. Just a little bit of bad spots here and there, which can be improved. But this tells me, okay, not an issue. 6 gigahertz. This environment does not support 6 gigahertz. That's why you see no signal. That's a good point. And if we want to see signal to noise ratio, if we want to check everything else, depending on what the client's looking for. But for today, the client was more concerned about a specific Wi-Fi on 5 gigahertz. Then the Wi-Fi is the same both on 5 and 2.4. As you can see, it's kind of weak. So the reason why the client is having a problem with this specific Wi-Fi over here is because they have an access point right here. And they're surprised as to why this access point propagates the signal, but it's not working here. It's because the access point is not configured to broadcast that specific Wi-Fi frequency. That's why during the survey, we had very good wireless signal, but once we filtered down to a specific 802.11 broadcast, we found a problem. This is why you conduct a Wi-Fi survey, and this is pretty much the end of the video. We're gonna recommend a solution, and I believe once it's fixed, they should have excellent signal coverage across the office. That's pretty much it. Peace out.